Hello world and hello YouTube. My name is Reggie, and today I'm going to talk about tree data structure iterators using Java. To begin, here is my outline, and before I can delve into the topic of tree iterators, I want to make sure that we are all on the same page. So first, I'm going to talk about what I expect you to know. And once we are all on the same page, I'm going to go ahead and explain how to walk through a tree through recursion. And once we have that knowledge, we're going to go ahead and implement it by transforming it into code, and that is going to be the flow of this video. What I expect you to know. So as I said, there is some basic fundamental information and knowledge that you should already know before we can talk about this advanced iterator. Firstly, I expect you to know about the enhanced for loop. It's because of the enhanced for loop that we use iterators. The enhanced for loop uses the iterable interface, and I already expect you to know that. I'm not going to go into detail about it. Of course, since this is an advanced iterator, I expect you to know about basic iterators, both for the array and the linked list. Speaking of the linked list is a data structure, so I already expect you to know about the linked list, including its node class, and the generics that come with linked lists. And also, I expect you to know about the wrapper class. When we deal with these kind of data structures, we typically deal with them in key value pairs. So as long as you can understand the wrapper class in that sense, then you should be solid. And of course, some sort of tree data structure. When we iterate through a tree, it doesn't matter whether it's a binary search tree or a red-black tree or an AVL tree. We're going to iterate through them the same exact way. I will not be talking about how to insert into a binary search tree or how to remove in a red-black tree or how to balance an AVL tree. I'm only going to be talking about how to iterate through these data structures, just so that we're clear. And that's basically what I expect you to know. So we're going to go ahead and move on to the recursion part of the presentation. So I have a simple tree here with 5 nodes. When we iterate through an array, it's very simple. We just go from one index to the next index. However, within a tree, it's harder to put it in order. So you can actually do this in post order or pre-order, but we're going to go ahead and put it in order, as in from in ascending order. So 20, 32, 39, 58, and 76. I'm going to go ahead and hop on over to some pseudocode over here on Microsoft Word so that you have more of a visual representation. So here's my pseudocode. We're just going to call the method iterate, and we're going to pass in a node. Now when we start for the iterator of a tree, we always start at the root. So what we have here, just so that you can understand what this pseudocode looks like, if the node that we're currently looking at is null, then we will return. Otherwise, we're going to do the rest. The next step we would do is iterate left, so we'd literally call ourselves iterate and pass in the left node. And then after that, we would store n's data actually, into our array. So you're probably wondering, well, why am I storing it into an array? The reason we're doing this is because we already have the knowledge of how to iterate through an array. With that prior knowledge, it's very easy. Once we transform this data structure and put it into an array, then we can simply iterate through it. And then after that, we're going to go ahead and iterate right, and that's basically the pseudocode that I have. So before we begin with the pseudocode, I just want to explain that I'm going to try to explain this in a top-bottom kind of fashion. When you see recursions normally explained as a stack, so it's bottom to top. Hopefully this helps you understand how the recursion works. It's helped me out, but this is just kind of like an experiment for you guys. So here we go. As I said, you start at the root. So let's go ahead and color coordinate this. So if I make any mistakes, just forgive me here. So we iterate at 32, and beginning with this pseudocode, we check, is 32 null? As a matter of fact, it's not. So we're going to go ahead and call iterate on its left child. 32's left child would be 20 here. So we call iterate on 20. Now what happens is on the stack we call iterate 20, and this is put on the stack, 20. So iterate 32 is not done because it still has store n to array and iterate right. what's going to happen is it's going to wait for iterate 20 to finish before it's popped off the stack. So let's go ahead and see how this is run. So we check, is 20 null? As a matter of fact, it's not, so we're going to iterate to the left. So to the left of 20 right now, its left child is null, because there's nothing there. So now when we call iterate null is put onto the stack. Iterate null. So now if we run into this if statement, is null null? Well, yes, it is, so we're going to return. So whenever we return, what happens is this call is popped off the stack just like that. And I'm not going to do this again whenever we run into iterate null, because I feel like it's straightforward that we can understand that. So now the next thing that's going to happen here is we're going to store. What are we storing exactly to our array? Well, we're in iterate 20, so we're going to store 20 to the array. So let's go ahead and put it in here, 20. Now the next piece of code tells us we need to iterate right. So 20's right child is null. Again, we already know that's going to return, so I don't need to put it onto the stack because we know it's going to be popped off right away. Now iterate 20 has completed all of the 4 steps that is required in the pseudocode. So now it is now popped off the stack, and that's what we get. And now we continue on as always. So now the next piece of code for iterate 32 is we're going to store 32 to our array. Store, excuse me, let's be blue. Store 32 to array, and that looks like this. And we continue on. So now we say iterate to the right of what? 20 is done. We're now 32. 32's right child is 58. So now, putting onto the stack, we get iterate 58. And we say is 58 null? No, it's not. Continue on. So we're going to go to the left of 58. Left of 58 is 39. And then we say iterate 39. Is 39 null? No, it's not. So we just go to the next piece of code here and we iterate to the left of 39. 39 has no children. So we just simply store 39 to array. Store 39 to array. And we iterate to the right. Again, I said 39 has no children. So now iterate 39 is popped off the stack because it has finished. Now we go and we're in iterate 58 now, and the next piece of code for that is store. So we need to store 58 to array, and it looks like that. So this happens, and the next piece of code is going to the left. So we're going to iterate to, excuse me, I said left, I meant right. We're going to iterate right of 58. So we're going to iterate 76. So if we go here, iterate 76. So we say is 76 null? No, it's not. 76 left child is null and its right child is null. So is, let's see here, oh, not is, iterate null. And then we're going to store 76 to array. Store 76 to array, and to finish up this code right here, we would just say iterate null. So now iterate 76 is completely finished. Iterate 58 is also completely finished. And finally, iterate 32 is completely finished, and this is what we get right here. Well, now we have an array. If you look at this array and compare it to, is this in order that we wanted? 20, 32, 39, 58, 76. Yes, we do. And that is exactly how we do recursion in a tree. Let's go ahead and take that knowledge and transform it into code. I already wrote a binary search tree class, and I have a method here that's called keys, and it returns an iterator of type keys, hence key iterator. and I also have one for values. If you notice that they both extend this iterator helper class, it's because of the fact that they're both going to do the same thing. They're both going to store the nodes into an array. The only difference is the next is going to return for value the values, and for keys the keys. So I actually have an abstract class, iterator helper, that allows me to do this. To save some time in this video, I'm only going to do it once. So if I pop on over to my notepad here, I have a public class binary search tree with my own wrapper class, which I'm calling node. And the rest of your code would go here. And this is my keys method. And I'm only going to do this once instead of also having the values, as again, just to save some time. So we have here the class key iterator helper of type K, because we want to return keys. Implements iterator K. Implements tells us that iterator is an interface, and we know from the array iterator we need to implement the two methods has next and next. So first, let's go ahead and begin with the constructor. So thinking of here the key iterator helper, we do know that we want to put this into an array, right? So I'm going to go ahead and node kv array. And when we're in an array, we know that we need an index. So let's go ahead and use an index, and of course a modification counter. That should be self-explanatory. So we know we just need to initialize these. So I need a new array here, new node kv currSize, however many elements I have. Index is always going to start at 0, and modification counter is going to equal to the mod counter that's in my regular class. Now after this, we actually need to populate our array. So the method that we were using in our pseudocode, we called it iterate. So let's go ahead and just use that, iterate. And as I said, we would use root. I actually have a root pointer, a node pointer that points to root. So that's what we're going to do here. So this is more of a private method. So let's go say private. This doesn't return anything, so that would be void, and we would call it iterate. And of course, this is going to be a node kvn. Right, so we check is n null. So if n is null, we would simply return. Otherwise, we would iterate to the left. So n dot left, and then we would store it. So we would store array at whatever index we were at, and once we store it, we need to move it. So we just increment like that, and then we would iterate right. And that is basically the end of iterate. Now what happens is, after we call iterate, we've just populated our array. So that puts our index now at the very end, but we haven't even iterated through yet. Next and has next hasn't called the index, and we are going to need that. So I need to reinitialize index to 0. And then now the next and has next method, it should be very much similar to what you've been doing for, actually it should be exactly the same as you've been doing for an array. So we have public boolean has next. You do the same things here. If modification counter is not equal to mod counter, or state check, whatever you would like to call it, you just throw new concurrent modification exception, and then you would return index less than the current size. For next, you were going to return k. Let's see, next. Then you would just say, if not has next, there's nothing there. So you just throw new no such element exception, and then you would return the array at the index plus plus, because you need to increment that. And that's basically how you now write it in code. Hopefully that's clear now. So now if I just go real quick over to Java, I do have this driver here that fills up the data into a binary search tree and prints those out using an iterator. I'll just run this real quick and you can see that it is in its proper order. That basically concludes my presentation today. Here are some of my credits of just the images that I used. Hopefully that you were able to understand more about the tree iterator. It's just me sharing my knowledge that I learned here at SDSU. If there's any part that was confusing because I was speaking too fast or I didn't explain it enough, feel free to leave a question down in the comments below and I will do my best to answer them. So all I have to say now is goodbye world and goodbye YouTube. Until next time.